Hey there, I am Bart Prankai, and today I will showcase our research titled Multimodal Condition Diffusion Model for Skeleton-Based Video Anomaly Detection, conducted in collaboration with my colleagues at Sapienza University of Rome within the Perception and Intelligence Lab. Our innovation, you might ask? A novel generative model that harnesses multimodal representations and exploits past frame conditioning to engender multiple futures for human motions. Let's delve deeper into this work in the following slides. As mentioned, the task here is to detect abnormal behaviors in video frames. In real-world scenarios, anomalies are rare and elusive, which demand specialized detection methods. And as you can notice from the slide here, abnormal behavior in videos is even more complicated. Here, some human motion is abnormal, but the majority is normal. Plus, you've got a lot of diversity between the two types of motions. Here, the people walking are considered normal, whereas the guy who throws his backpack and does abrupt movements is anomalous. Generally, models for video anomaly detection are considered one-class classificators. They focus only on normal data, which neglect the diversity of normal behaviors. For example, the walking people have different strides and can move laterally as the security guy in the foreground. All these components, even with the normal data itself, might make the task very complex. The main intuition behind our approach, MoCoDat, is to exploit past motion conditioning to forecast future motions. The idea here is very simple. Normal past motion should lead to coherent forecasting, while abnormal past motions should produce erroneous forecastings. This is consistent with what happens in reality. If people walk into a scene, they tend to keep walking and have a predictable behavior, whereas abnormal behavior instead has unpredictable futures. Thus, they should be detected as such. MoCoDat detects anomalies by synthesizing and statistically aggregating multimodal futures motions conditioned on past poses. This is how MoCoDat works at a high level. It gets all the actors in a frame and uses past frames of these actors to condition the generator of multiple future motions. Then it compares the generated future motion with ground truth. This comparison produces several anomaly scores for each of the actors in the frame. We select the maximum anomaly score to determine whether the frame is normal or abnormal. In our setup, we have two contexts. The first one is anomalous, which is depicted in red, and the other one, which is in green. Red dots here mark the ground truths. When the past is normal, then the true future aligns with one primary mode, which leads to accurate predictions. For abnormal pasts, the true future lies in the tail of the distribution, which results in less accurate prediction, highlighting anomalies. MoCoDat generates multiple future scenarios, and we select the closest to the ground truth. Here's how MoCoDat works in detail. A sequence of skeletal motions is split into past, the top right frames, and into future, the top left frames. During the training, the forward diffusion block adds noise to the future frames, shifting each joint by a random vector displacement, which varies in intensity. Then the reverse diffusion learns to estimate the noise, which is conditioned on the latent representation of the past obtained via an autoencoder. The conditioning is optimized jointly with the diffusion process. We compare MoCoDat against the state-of-the-art on HRSTC, HR Avenue, HR UBNormal, and UBNormal. MoCoDat outperforms COSCAD, the current best, by up to 4.4%, which demonstrates the importance of different possible futures for each sample. MoCoDat also achieves an AOC of 68.3 on UBNormal, which surpasses COSCAD by 5.1%. Considering more than a single deterministic future smooths our prediction. In fact, it avoids penalizing excessively hard but still normal samples, which would be considered abnormal based on classic reconstruction error of a deterministic model. Here, we leave you with other online resources our team has created to check MoCoDat in our project. Thank you for your attention.